So let's look at the next part. We want to find the area under the curve, which is whole thing here. I think it's pretty okay. If you want to find the whole thing here, just make sure that you know that we need to write in Cartesian form first before we move on, right? So for part 3, required area will then be the integration of 0 to 1, I believe, 0 to 1, and y dx, right? And then we know that y, now we need, our goal here is to change this to parametric form. So we know that y is equals to sine cube t, and dx, okay, dx dt we found, right? Dx dt is actually, dx dt is, where's our dx dt? Here, 3 sine t, so I'm going to write this down. Dx dt is actually 2 cosine t minus sine t. Alright, dx dt. Oh, that's dy dt. Dx dt is this, right? Great. So, now take note, this case here, dx will then be 2 cosine t sine t. So of course, please erase this away. If not, actually, I think it's fine, but if you don't allow to write this, then just make sure that you just erase away. So now our whole goal here is to change this to parametric form. So sine cube t dx dt, which is actually minus 2 cosine t sine t dt. Okay, so I just replace the whole thing here. Then what we need to do next is essentially, this is the important one. This is where the careless mistake comes in. If you change your dt, just make sure this boundary condition change as well. It should change to the parametric form, parameter. So x, when x is 1, that's why this labeling is important. When x is 1, right, for the curve, we know that t is 0. So this one will correspond to 0 here. And when x is 0, it will correspond to pi over 2. You could just quickly write it down. So you just, if you trace pi over 2, you get here 0, 1, right? So this is pi over 2. That's how you change the boundary there. Okay. So this case here, once done, what we can do is actually just this is 0 pi over 2. Then I'll just bring this out. So this is, I'll bring the negative 2 out actually. So this will be cosine t sine the power of t dt. Great. So because we are told to show this, do you see this negative here? We just need to absorb it up. Then this will be pi over 2. We can just swap down and up. Okay, cos negative abfx dx is equals to abfx dx. Take note. Okay, so this case here will be cosine t sine 4t dt. So this is shown. Of course, if you can't show this, is fine. Just make sure you do the subsequent part, which is using the substitute u equals to sine t. Okay, so du dt here will just be cosine t. So I'm going to just replace this. So when t equals to pi over 2, u equals to sine, just replace this, sine pi over 2. Sine pi over 2 is actually just 1, right? Yeah, then when t is equals to 0, u is equals to sine 0, it's just 0. Okay, so just take note. Same thing, when we change, we need to change it. So when this is 0, it is 0. And when this is pi over 2, this is 1. So this is 1 and 0. Cosine t is actually, cosine t is, okay, we're going to just change this. Cosine t, sine t will be u to the power 4, then dt. So this is actually just u substitute method, cancelling method. You will get cancel away this, is fine, and you get this as u to the power 4 du. So this will just be u 5 over 5, 1, 0, and 2. So this case will be just 2, 1 over 5. So it's 2 over 5 square units. All right. So that's how we do this question here proficiently. If you have any questions at all, please do let us know. Keep practicing, and I will see you in the next question.